so let's talk about tokenization. Tokenization is basically converting raw text, basically the human text, human language, converting into the into a meaningful tokens. Basically, it is called MPU, model processing unit, so that our model, any large language model, can understand. Yeah. So why we need tokenization? First of all, why we need tokenization? So because tokenization, basically, the any language model or in any computer system only understand numbers, and whenever we give the input as a text, so they can't understand, so we need to convert into the number, and the tokenization is the process of converting raw text into number. So, and before tokenization, so we need to perform standardization. So standardization is nothing but, to ensure consistency, we need to perform some method, like some operation. Like first operation is like, we need to perform lowercase capitalization. Like I want to do the lowercase, I want to convert all the text into lowercase. And the second method is like, we can remove the punctuation. So, and the third is like, removing the special characters, are like, Turkish language has some tilde on every character, so we need to change into the main characters. Okay, and after that, so when standardization is done, then we can do the tokenization. So there are three ways. Basically, there are three ways to do the tokenization. The first one is word level tokenization. The second is a character level tokenization, and the third is subword tokenization. So let's talk about one by one. The first one is word level tokenization. Word level tokenization is basically converting each word into a token. So basically, for example, I am learning machine learning. So I is a one token, every word is a token. So this is as simple as possible. But the problem is, our vocabulary size become very large. How it is very large? Because some, like for example, run, runs, running. So run, running, runs. So this tokenizer treated all three different tokens. So the vocabulary would be increases. Okay. The second tokenizer is, the second tokenization method is, character level tokenizer. Character level tokenizer is basically, uh, converting each. So for example, converting each. So basically, it is splitting all the words into a characters. So for example, cat is basically, uh, uh, splitting into CAT. So there are three tokens. So by using character level tokenization, we can build any word, but the sequence size will become very large. Okay. So yeah, its vocabulary also is very small, and its vocabulary size is very small. So you can see, like, by using word level tokenization, the vocabulary size become very large, and when we use character level tokenization, the vocabulary size is very small. Why very small? Because we can have only A to Z characters now, so maximum 26. And the third level, that's why we need to trade off between both, word level and character level. So that's why the third tokenization method is the subword tokenization. In this, so basically, each word is each text is divided into subwords. It may be like, for example, a GPU, or let's say annoyingly. So annoyingly is a single word is treated into two tokens, annoying and, uh, ly, annoying illy. So two words, so two tokens. Okay. And you know what? Most of the modern LLM uses only subword tokenization. For example, GPT-3, GPT-4 uses only subword tokenization, and even bot everyone uses subword tokenization. So let's talk about subword tokenization in little bit detail. So subword token, there are two algorithm for subword tokenization. The first one is very popular, BPE, byte pair encoding. And so this is basically, so means, subword tokenization is basically combination of character level tokenization and word level tokenization. So in BP, first we just divide each word into a characters. So the vocabulary is like our characters, and then we repeatedly merge the next adjacent tokens or pairs of next adjacent pairs of tokens into characters based on the most frequent pairs. So basically we just merge the most frequent words or words subwords into the characters. So this is the way. So yeah, and the second subword tokenization method is WordPiece tokenizer algorithm, or WordPiece tokenizer. In this, basically same, just divide each word into characters, and we repeatedly merge the next subword, but the merging process is based on but the merging process is based on most uh, uh, probability, likelihood, most likelihood, or most probability. So based on probability, the merging process is probability instead of most frequent. Okay. So yeah, and the so GPT-3 and GPT-4 uses BP, and but uses WordPiece. So yeah, this is the answer.